Here's a summary of the inverse functions and their domains and ranges. So sine inverse, the angles that we choose from, the output values for sine are going to come from quadrants 1 and quadrants 4. And remember that the angles in quadrants 4, we think of them as negative angles. Cosecant, the reciprocal function, has exactly the same range, meaning that we choose also from quadrants 1 and quadrants 4, and once again the angles in quadrant 4 are thought of as negative angles. Tangent and cotangent. Tangent has output values that come from quadrants 1 and quadrants 4. However, I want to keep this in mind. For cotangent, the angles that we choose come from quadrants 1 and quadrants 2. So these are the only two that have a reciprocal relationship that are different output values for those inverse functions. Both cosine, the inverse function for cosine, and the inverse function for secant both come from quadrants 1 and 2. So we can actually use the reciprocal relationship to determine the angles for cosecant, cotangent, and secant. So let's look at a couple of examples of that. For example 4, we are looking for the exact measure in degrees of the indicated angle. So we are looking for arc cosecant of the cosecant value, -2 divided by the square root of 3, and so we're looking for the angle that has that cosecant value. To determine that cosecant value, we can use the reciprocal function to help us think through that. When the angle has a cosecant value of -2 divided by the square root of 3, then at the same time we are thinking about a sine value of the reciprocal. So we can use the reciprocal of both. So the reciprocal of the function, reciprocal of the input. So what we're looking for now is what angle has a sine value of -square root of 3 divided by 2. So the same angle that has a cosecant value of -2 divided by the square root of 3, that same angle has a sine value of -3 divided by the square root of 2. So what angle would that be? We look on our unit circle, and remember that we have to look for angles in quadrants 1 and quadrants 4. And we think about the angles in quadrants 4 as being negative angles. So this is our 60-degree family, so we'll think about that as -60 degrees. Okay, for part B, we're looking for the arc secant of -2 times the square root of 3 divided by 3. So we're looking for an angle, and the angle that we're looking for has to come from the same two quadrants that cosine comes from, which would be quadrants 1 and quadrant 2. And we're looking for an angle that has a secant value of that, but then also at the same time we can evaluate this by looking at the inverse function and the inverse of the input value, which would be, let's unrationalize that before we do this. Before we rationalize, the answer, or the value for the fraction would have been -2 divided by the square root of 3. So let's unrationalize and then we flip it. So that would be -3 divided by the square root of 2. And that's our 30-degree angle family. But we are supposed to find a value either in quadrants 1 and quadrants 2. In quadrants 1, the values are positive. So we're looking for an angle that has a cosine value that is negative square root of 3 over 2. So we are going to be looking in quadrant 2. And that's our 30-degree family. So that would be 150 degrees. So we look on our unit circle, find the x value on the unit circle that's negative square root of 3 over 2. Find that cosine value, and that would be 150 degrees. So we're looking in quadrant 2 for cosine. Last one here, cotangent inverse of negative square root of 3 divided by 3. And for cotangent, we have to report values from quadrants 1 and quadrants 2. Just like secant and cosine, all three of those, we look in quadrants 1 and quadrants 2. And for this one, let's think about what the cotangent value is. Let's unrationalize first, so that would be negative 1 divided by the square root of 3. And remember that cotangent is x over y. So we look on our unit circle, we want to find an x value divided by a y value that would reduce to be negative 1 divided by the square root of 3. And of course that would have to be, before we simplify, that would look like this, negative 1/2 divided by square root of 3 over 2. We're looking in quadrant 2 because our value is negative. So what degree measure in quadrant 2 has an x value of negative 1/2 and a y value of square root of 3 divided by 2? And that would be our 60-degree family. So, but in quadrant 2, we're looking for 120 degrees. For example 5 and example 6, we will be using our calculators. And for the first example, example 5, we are looking for decimal degrees. So make sure that your calculator is in degree mode. So we're going to type this directly into our calculator. Arc cosine, and this wouldn't be here. Just be arc cosine of this, and of course that's the same thing as cosine inverse of this value. So we're going to type that directly into our calculator. And we're going to round to the nearest 2 decimal places. So you should get negative, or 97.67 degrees. So theta has this angle theta has a cosine value that we were given here. And remember that cosine, our calculator is going to spit out values from quadrants 1 and quadrants 2. And this comes from quadrant 2. Theta equals cosecant inverse of this value. Now we don't have a cosecant inverse button on our calculators, so we're looking for the angle that has a cosecant value of this. Well, the same angle that has a cosecant value of 1.94, etc., has a sine value of the reciprocal. So we're going to look for sine inverse of the reciprocal of that value. So we're going to put that into our calculator, round to the nearest 2 decimal places, get 30.99 degrees. Now for example 6, we are looking for real number values. So we're looking for angles in radians. So we're looking for a real number, which is, in other words, for finding an angle in radians. And we're rounding to the nearest 6 decimal places this time. So we're going to directly compute this into our calculator. Sine inverse of this sine value. Remember that we're looking for an angle. And I get negative 0.133881. So there's the angle in radians that has a sine value of negative 0.133, and so on. Okay, the last one, we have y equals arcsecant of this secant value. So we want to know what angle has this secant value. We do not have a excuse me. We do not have a arcsecant button or secant inverse button in our calculator. So we're going to go to cosine. We're going to take the reciprocal of the function and then the reciprocal of the input. So we're going to put this under 1. We're going to take the reciprocal of the function and the reciprocal of the input. So we're looking for an angle that has this cosine value. We're going to type that into our calculator, and I get a radian value of 2.48024. So this is our angle in radians that has a cosine value of this value, this fraction, and a secant value of the reciprocal.